Lesson 6.5, Properties of Special Parallelograms. Broke it into 3 parts. We are in part 3, square. Oh yeah, let's learn something new. Objectives, square. We're going to use properties of rhombuses, rectangles, and squares to solve problems. Squares have the same properties of parallelograms, rectangles, and rhombi. That's why this is part 3, because we already went over parallelograms and rectangles and rhombi. Okay, opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other and are congruent. All 4 sides are congruent. All 4 angles are right angles. Diagonals are perpendicular and diagonals bisect opposite angles. There's all of our properties. Properties of squares, example 1. This quadrilateral is a square. Length of segment AD is 11. Let's mark that, and all the right angles. Find all the requested measurements, round to the nearest tenth when necessary. So let's see, all 4 sides should be 11, which gives us length of segment BC. Let's hit the angles. So we know all 4 angles are right angles. So those are 90. And all of those are 45 because the diagonals bisect opposite angles. So we have our other 2 angles. And look at length of segment AC, that's a diagonal. Length of segment BD, that's a diagonal. Those are the same. And length of segment EC is half of a diagonal. So let's just look at what's going on here. So we have this right triangle that will give us length of segment AC. We have the 2 11s. It's 45, 45, 90. So that is our special right triangle. Length of segment AC is going to be the square root of 2 times the length of a side. We did that in our last unit. We can calculate that and we get 15.6. Length of segment BD should be the same, and length of segment EC should be half of that, which is about 7.8. Properties of squares, example 2. This quadrilateral is a square. Length of segment TR17. And since diagonals bisect each other, all those pieces are 17. So length of segment QT is 17. That's the one they asked for. And these 2, length of segment PR, that's a full diagonal. And length of segment QS, that's the full diagonal. So if we add the 17s together, those are both 34. Let's see, a square is 4 right angles. So this gives us a 90 degrees. Measure of angle PSR is 90 degrees. And diagonals of a square are perpendicular. So that gives us measure of angle STR is 90 degrees. Other angles, those are going to be 45 degrees because diagonals bisect opposite angles. There's a 45, 45, 9-degree triangle, and that's what we're going to need to find the hypotenuse, which is length of segment PQ, because that's the last blank that we have. 45, 45, 9-degree triangle. Remember, a hypotenuse is the square root of 2 times the length of a leg, and we have the length of a leg is 17. So the hypotenuse, PQ, length of segment PQ, is 17 times the square root of 2. Put it in our graphing calculator, and it's about 24.0. Select all that applies. So this is about special quadrilaterals, not just the one we're talking about in this part. Which quadrilaterals always have diagonals that are congruent, and that's rectangles and squares. B, which quadrilaterals always have consecutive angles that are supplementary? Well, that's true for parallelograms, which means it's going to be true for all four. Parallelograms, rectangles, rhombi, and squares. C, which quadrilaterals always have diagonals that are perpendicular? Perpendicular bisectors are for rhombi and squares. D, select all that apply. Which quadrilaterals always have diagonals that bisect each other? Once again, that's a property of parallelograms, so it's going to be true for all four: rectangles, rhombi, squares, and parallelograms. And we have now finished part 3 of lesson 6.5 notes. Special parallelograms, this time square.